Yeah, and so we kind of have a convenient way that we can rewrite this to make it look a little more useful. Again, if we think of R of T as being a parameterization for C, okay, so then, like I have written right here, I'm going to write a little bigger. T of T equals R prime of T over the magnitude of R prime of T. And we actually, again, kind of thinking back just a little bit to last week, we saw that dx, which was that kind of, remember S is arc length, so we can think of the change in arc length as being dx dt squared plus dy dt squared plus dz dt squared. But what this really is equal to is just the magnitude of the tangent. And so then ds equals the magnitude of the tangent vector times dt. So that was kind of that change of variable that we use to carry out this integral. Okay, and so if we kind of substitute this all back in, we're going to have the integral over c of f of x, y, z dotted with r c, r prime of c over the magnitude of r prime of c times the magnitude of r prime of c. That's going to be recorded forever. There we go. R prime of c. dt. And so notice that these cancel out. And we come down to this nice kind of concise formula. And so a lot of times this is kind of also abbreviated a little more shortly. Remember how we up here we call dx the magnitude of r prime of t dt. Well, we can call r prime of t dt. We kind of call this little notion, this little thing right here, just dr. And so the other way it's often written is the integral over c of f dotted with dr. So it's a little kind of funny to think of having the dot product of our differential in the dot product or in the integral, but this is really all it means. It's just dot product of the vector field and the tangent vector. Okay, so this is kind of, all the different ways we have to write it. We have f dot with dr. Here again, we kind of think of RC as being a vector, so this is a vector function on a vector, dotted with the derivative or the derivative, or f dotted with the derivative. Okay, so that's how we define a line integral through a vector field. So let's kind of look at, let's have a look at, oh yeah, I already said that, so.